Rightio, we are going to do section B. Just going to go over it. Write a program that gets 2 words from the user and then displays a message saying if the first word can be created using letters from the second word. And there was some examples. It's important to read those to understand exactly what you're asked of. And here we're told if it was meet, M-E-E-T, and then the second word was M-E-A-T, it doesn't work, that we needed 2 E's at least. So once you'd read that, you understood what was happening. Now, you've got to do a bit of planning for this. Not too much, doesn't take a long time. And one bit of advice actually is just to see if you can draw a trace table. That could be one way into it. Or a little bit of a flowchart or something, just get a bit of a plan together, however you want to do it. I'm going to use some examples and I'm not going to generalize too much. I'm going to use some actual words that I can make sense of quite quickly. W1 is meet, W2 is that meet, and then I can start looking at whether it's going to work or not. So the strategy I'm going to go for is I'm going to see how many M's are in here, how many M's are in here, and then compare them. It could be a bit fiddly to sort of start with the M, then the E, then the T. And I'm not going to worry in actual fact about being super efficient with this algorithm. So I'm just going to go through all the letters in the alphabet. It's easy enough to do, to program it. It just makes it a bit easier. I'm not saying you have to do that, but I want to count how many A's there are in both of these. So I think what I might do is just call it something like letter count, say. I'm going to do a letter count of W1, and I'll do the same there as well. Just count the letters, the occurrences of that particular letter for the second word. So for A, there was 0 of them, there was 1. Now then, I am just comparing the number of times that they occur. I'm using this kind of inequality symbol, and here this is not bigger than that, so I can move on to the next letter. So I'll move on to the next letter in the alphabet. 0 of them, 0 of them, and I can move on to the next letter, etc., and the next letter. Now, interesting, when I get to E, so I can keep moving, I'm kind of doing some iteration, we know that. Now I've got 2 of them. I've got to think of a program, by the way, of can I count how many occurrences of a letter is in a word. I've got to get to grips with that quite quickly. But here I've got 1. And I'm checking to make sure that this value here is less than that. So if this occurs, if this number is bigger than that, like we have here, I've got to stop. Got to stop the program at that point. So that little bit of planning is going to be incredibly useful for us. The other thing that's going to be useful is just to sort of say, right, so if you've got this word and this letter, how do you get the number 2? How did that work? And so you've got to think about some sort of construction, and you're going to have to go through each letter and compare it and sort of count it in some way. So I want to go through how we could possibly do that little bit. I'm going to have a variable called count that's just going to count the number of occurrences of a letter. And I need to just go through and iterate through every character in the string. A really easy way of doing that, of course, is definite iteration for character. You could have said whatever word you like at this point. For character in meet. Something like that. And I'm not too worried if this Python code isn't quite right. It's just a bit of a rough idea. And then I'm going to say if character is equivalent to, I'm going to say E. And pick up this actual example here. What will happen if then count goes up by 1? Count is equal to count plus 1. So that's going to be really, really useful, that little bit of coding there. Just want to sort of give you a little word of warning with this. The kind of programming skills that we're looking at here are kind of GCSE, and they are to do with iteration, selection, Boolean variables, string manipulation, the use of data in an array, and those sorts of bits and pieces. And the question is you're trying to demonstrate your algorithmic thinking skills. It's not an IT question. In other words, don't use any really fast and clever programming keywords in Python in order to achieve it, because you'll lose the marks. It's not about can you solve this problem, do you know some clever words that can do it. It's about can you demonstrate your algorithmic thinking skills. So look for opportunities to use for, if, while, some Boolean things and those bits and pieces. Just before we start coding up, I want to mention a construct which is incredibly useful, and it looks like this. It's a while loop. I'll just get a piece of paper if I can and just talk about it very briefly. The while loop is very, very useful, and you can have more than one condition in a while loop, and that's really important. So while loops, of course, are they are indefinite iteration. We don't know how many times it's going to loop through before the programs run, and we might want to have something set up so it will stop if a particular condition is met. So the use of a Boolean variable is really, really important here with this kind of thing. So really useful, rather. So let's say we have something like this: fine is equal to true, or you might have run or something like that, or whatever the condition is. And I can also control it on sort of counting as well. So I'll just put count as equal to 0. So if I wanted to go through every single letter of the alphabet, like I did in my program, just thinking of my program as a trace table, I want to go through every single one, and I can count through every single letter. I want to stop when I get to 25, as it were. So I can say something like this: while fine, I could put e is equivalent to true, or just leave it as while fine, and count doesn't exceed 25, so it's less than 26. That's a really nice thing, and it's a construct which is used time and time again. So make sure that you're happy with this idea, that I can, and you know, somewhere along the line I might have a count equals count plus 1. So this is a very common structure to have with indefinite iteration, that you have these two conditions. So that sort of thing, I think, is going to be the thing that's going to work for us in this particular program. So we've done enough planning. Let's go and actually code the thing up. Rightio, we're going to have a look at this trace table and start to get some bits and pieces out of it. We certainly want the two words, so we can say w1 equals input, and then just, you know, enter first word. Don't need the /n, and w2 equals input, enter second word. Again, just /n, and so that's that bit, and that'll get you a mark, actually, just getting those inputs right on that part of it. The other thing that we're going to need, and we may as well do it now, is we want to go through all of these letters of the alphabet, so it's useful to have those somewhere as well, actually. Here's a string I prepared earlier. Don't put it in an array, just work with a string. You know, the things that you can do with strings, I'm just going to comment these out just for a second when we're doing our testing of bits. You know, if you've got this kind of thing, print alphabet, just make sure you're okay with your string manipulation. I'm going to put 1 in there. What's that going to print out? Prints out the first character of the string. What would 25 be? Z. It does mean that we're going to be in trouble if we try to go out of that range. So we certainly don't want to exceed 25 when we're doing that. So having the alphabet is going to be very useful for us, just having those bits in. Rightio. Actually, I might just keep them commented out for a minute. Okay, what's next? Now it says letter count of W1. So I need to write something where I can count the number of times a letter occurs in a string. So this was the little bit of code that we'd thought about. You don't have to think now, do you? Because you've already done it. Sorry. just use actual words to begin with. Don't generalize too much to begin with. And I just want to print off that count and just check that it's right. Is it giving me 2? Yes, it is. So that's really nice. Now then, just looking at your program, you need to be doing it lots of times. So because you're repeating that block of code, you want to write this actually as a subroutine. So we're going to call it letter count, maybe. Dead easy to do. Just give it a name and tab everything in. Or out, whatever. Meet now, we can write as just generally is going to be a word. That becomes our first parameter. And similarly for E, that becomes letter is our second parameter, which we shall put in there. Okay. Let's just run through that. Letter count, just want to check that it's okay. Here's our first argument is going to be meet. And our second argument is going to be the letter E. Let's check that it works. And it does. Okay. Now, it's useful when you have subroutines to actually return values rather than print them. Just imagine if you've got a GUI, you know, you don't want to be printing stuff to the runtime environment. You want to be able to do something with it. So returning is always a very good thing to do. You can, of course, now capture that value just by, when you make that function call, assign it to a variable, and you can do what you like with X now. It's much better. You can print it if you want to, but you can do other things with it, like compare it and stuff like that. So returning values is very important because it gives you a lot more flexibility. The other thing that you should be aware of, just in the same way with your maths, when you've got, you know, f of x equals x squared or something like that, the f of x notation that you have in maths is the same notation that we've got here with this function. You know, that the entire thing then has a value. You know, it has a value 2. So the actual function call then becomes the return value. So that's also very, very useful. So we'll want to be able to, you know, use this function. You give me a word, you give me a letter, I'll tell you how many times that letter occurs inside that word. Go back to this thing again. We've got these bits and pieces. We've got the word 1 and the word 2. We've got our thing which is our letter count. We've made letter count there so we can do it. Now we want to go through all of these little letters, and there's a construct which is so useful for us, this sort of thing. We may as well just type everything out that we've got here just to begin with, because it's such a common thing, this collection of statements. I'm just kind of copy them out without thinking. So we've got that. Okay. Now then, let's go back to this thing here. I want to calculate this number and calculate this number and see if this one is bigger than that one. So I need an if statement. So if this number is bigger than this number, fine is going to be set to false. I can't do it. So let's just write that in. Oh, before I can do it, I need to get hold of letter as well. I need letter before I can do anything. So let's do that. Letter is equal to, and here it's A, which actually is the first letter of the alphabet. This is how you say first letter of the alphabet, but even better is just use that count. Don't worry that we've used a count here. This is local. It doesn't interfere with this one, so I'm happy to use that count again here. You could have used something else if you wanted to, of course. So letter, alphabet count, in this case, alphabet 0, A. So the letter is A. Now I can go back to this thing and say, this number, that was the letter count for W1, so let's do it. I'm going to put an if statement. If letter count of W1, that's the word, and the letter is letter. I think it's quite a good idea that, you know, this parameter here is called letter, and the argument that we're sending is also called letter. I haven't got a problem with that. I think that actually makes it sort of quite easy to read, but they're not the same thing. You know, this letter is local to this thing here. I'm just passing the value letter, but I'm calling it letter. Oh, stop going on and actually do the program. sorry, just W2, and then just letter again. So that line here is this line that we've got, we're looking at this thing. If this number is bigger than that number, what do we want? We want to stop. How do you stop a while loop? You use this Boolean value here that we've got. So fine then becomes false. That's kind of it. The only thing is, if that isn't the case, we want to move on to the next letter. How do you move on to the next letter in the alphabet? Well, count needs to go up by 1. Obviously there's quick ways of doing that, but that's okay. Right, so very straightforward, the last little bit. So if fine is equivalent to true, if fine is alright, you just do that. You can print off whatever you want. What we got, W1 plus can be made from W2, etc. And then we'll have an else as well. Okie doke, let's just put in else, and then that little bit. Ooh, that's it. Oh, sorry, yeah, gotta be careful with cut and paste. Cannot, Radio, let's run through it, see if it works. Let's go meet, and let's go meet. Cannot be made, and let's run through again and go meet, sorry, and temper. So yeah, okay, that's it.